Hello, welcome to Engineers Mindset Academy. So today we are beginning a new series in physics in preparation for the forthcoming 2024 Jamb examination. So we are targeting consistent topics which have been repeated over time in the Jamb examination. Okay, so today we'll start with the very first topic, which is fundamental quantities, derived quantities, and their units. So at the end of each topic, we are going to be dealing with at least 3 years past question review just to explain everything we have talked about in the video. So do well to watch till the end, because after the explanation, we are going to be doing 3 years past question review in Jamb. Stay tuned while we begin the class. So our first topic is fundamental and derived quantities / units. Okay, so this particular topic has been repeated over time in the Jamb question, so it's always a very important topic for you to know. What are fundamental quantities? Fundamental quantities are those quantities which do not depend on any other physical quantity to be defined. They are simply those quantities in physics which do not depend on any other physical quantity to be defined. Now, when we say quantity, we are simply talking about what you know as velocity, acceleration, mass, length, displacement, as much as any physical quantity you can mention in physics. So these are simply called physical quantities. Now, amongst all these quantities I've listed, there are some quantities which do not depend on any other quantity to be defined. Those quantities are called fundamental quantities. It means that you don't need to combine two or more quantities to find them. They exist on their own, so they are simply called fundamental quantities. Now, in physics, we have 6 fundamental quantities. In physics, we have about 6 fundamental quantities. What are these quantities? We have mass, we have length, we have time, we have temperature, we have current, and we have amount. So these 6 quantities are fundamental quantities that exist in physics. Now, amongst these 6 quantities which I've listed to you, every other quantity in physics centers around majorly 3 of these quantities. Now, these 3 quantities are called the mass, the length, and the time. But then, let's take a look at these fundamental quantities which I've stated, and let us see what we can learn from it. So, I said we have about 6 fundamental quantities in physics. The first is the mass. Okay. The second is the length. The third, we have the time. The fourth, we have current. The fifth, we have temperature. And finally, we have amount. Now, let's take a look at their units. So these are the quantities. Let's take a look at their units. So these are quantities. And let's take a look at their units. The unit of mass, of course, we know is kilograms. Okay, so short form is kg. The unit of length, of course, we know is meters. Short form is m. The unit of time, of course, we know is seconds. Okay, so simply x for short form. The unit of current, we know this to be ampere. Okay, short form is capital A, or you can simply write amp. The unit of temperature, of course, we know is Kelvin. Okay, which is simply K. And finally, the unit of amount is given as moles. Amount is measured in moles. Okay, short form is MOL. All right, so these are their units. So it is important for you to know that the unit of fundamental quantities are simply called fundamental units. So if we define fundamental quantities as those quantities which do not depend on any other physical quantity to be defined in physics, then it also means that fundamental units are those units which do not depend on any other units in physics to be defined. So you don't need to combine 2 or more of the units to find what fundamental units. They are simply called fundamental units. They are self-dependent units. So the units of the fundamental quantities are simply called fundamental units. Hence, we also have about 6 fundamental units in physics, and these are the units: the kilogram, the meters, seconds, the ampere, the Kelvin, and of course the moles. The unit of the fundamental quantities remains the fundamental units. Now, I said earlier that about three of the fundamental quantities mentioned here combines to produce every other physical variables in physics or every other physical quantities in physics. About three of them, and these three fundamental quantities are simply what? The mass, the length, and the time. These three combine with one another to produce virtually all the quantities we have in physics. For instance, let's talk about area. Okay, let's talk about area. Area is simply defined as what? Length times width. The area of a body is defined as the length times the width, and the unit of area, of course, is meters or squared. Now, take note, this is quite a shortcut to understand fundamental quantities. Always, the very best way to know if a quantity is a fundamental quantity or a derived quantity is from their unit. It's very easy with the units. From the unit, you can easily tell. For instance, the unit of area here is meter squared. And if you look at the fundamental quantity, the unit of length is what? Meters. And then we're having what? Meter squared for unit of area. So which means that area actually what? Is a combination of what? The length or the unit of length multiplying itself twice. Okay, so which means length invariably times length, or which is meters times meters, which actually give us what? Meter squared. And length is a fundamental quantity. Length is also a fundamental quantity. So which means the fundamental quantity length multiplied itself twice to what? Obtain the area. So let's fall back here now. We said area is length times width. The unit of length we know is meters, and the unit of width we know is also what? Meter. So width is actually the length measured in the width of an object. Okay, direction of the width of an object. So which means we have meters times meters, which actually give us what? Meter squared to be the area, unit of area. So the very best way to know if a quantity is fundamental quantity or a derived quantity is from their units. So notice now that we have what? Meter squared, which means meter times meter, and meter is a fundamental unit of what? Length. Meter is a fundamental unit of length. So which means that area now is not a fundamental quantity, but simply what? A derived quantity, because it depends on the fundamental quantity. Now, having said this, let's fall back to derived quantities now. What then are derived quantities? Derived quantities are those quantities which depend solely on the fundamental quantities to be defined. Derived quantities are those quantities which depend on two or more of the fundamental quantities to be defined. Now, apart from these six quantities which I've listed here, every other quantity in physics are all derived quantities. And their units are also called derived units. The units of the derived quantities are called derived units, which means that derived units are simply those units which depend on the units of the fundamental quantities to be defined. They are those units which depend on two or more of the units of the fundamental quantities to be defined. Every other quantity in physics, apart from the six which I've listed on the board, are all derived quantities. Now, I've given an instance with area. Let's try another instance. Now, let's say we are to investigate if volume is a fundamental quantity or a derived quantity. And I said the very best way to know if an object is a fundamental quantity or a derived quantity is simply from the unit. The unit of volume we know is what? Meters cubed. This is very easy, a very easier way to what? Obtain if a quantity is fundamental or derived. Now, the unit of volume is meter cubed, which means that meter multiplied itself into three places. So I have meters times meters times meters. That gives me what? Meters cubed. And if you look into the fundamental table, you notice that meter is a fundamental unit of what? Length. So which means this is actually what? Fundamental unit multiplying itself into 3. So you have simply what? The length fundamental quantity multiplying itself into 3 to give you what? Meters cube. So which means that volume depended on what? The fundamental unit 3 times to obtain what? To obtain its unit. Hence, since the unit here is a derived unit, it also means that the volume itself becomes what? A derived quantity. Take note now, meter cube needed what? Fundamental unit of length, which is meters, to multiply itself 3 times to obtain what? Its unit, which is meter cube. So which means this unit is actually what? A derived unit. This is a derived unit. and the unit of a derived quantity is called a derived unit. So which simply means that the volume itself is also what? A derived quantity. Okay, so volume is a derived quantity, and of course its unit meter cube is also what? A derived unit. So let's take a look at let's say we are to investigate velocity. Let's investigate velocity. Once again, the best way to know if a quantity is fundamental or derived is from the unit. It's very okay from the unit. And unit of velocity we know is what? Meters per second. This is the unit of velocity. And once again, meters, remember, is a fundamental what? Unit of length. So which means we have length here invariably, and seconds is a fundamental unit of time. We have seconds. So which means we needed what? Combination of what? Length and time to produce velocity. A combination of length and time. Let's simply use time. So we needed combination of length and time to produce what? Velocity. This is a fundamental unit of length, and seconds here is a fundamental unit of time. So the two of them combine to give us velocity, which means that this unit is what? A derived unit, because it depends on two fundamental units to be defined. And the unit of the unit of a derived quantity is simply a derived unit. So if this is a derived unit, it means that the velocity itself is also what? A derived quantity. Okay, it means that the velocity itself is also a derived quantity. So I can go on and on to mention. For instance, let's also consider pressure. Let's consider pressure. We know that pressure is what? Force all over area. All right, we know that pressure is force all over area. We have already explained area here. Unit of area is meter squared. Okay, so you have this to be what? Meter squared. Okay, and unit of force is the newtons. But we know that naturally force is actually mass times what? Acceleration due to gravity. Once again, you're seeing a fundamental quantity here, mass. You're seeing a fundamental quantity there, mass, and then you're seeing an acceleration there. So this is actually unit of mass we know is the kilogram. The unit of acceleration we know is what? Meter per seconds squared. Once again, meter combining with what? Seconds squared or time squared to give us acceleration. So which means without being told, Newton is actually what? A derived unit, because you're seeing that force, first of all, is mass times acceleration, and mass itself is a fundamental quantity, and the unit of it is what? Kilograms. Whereas acceleration has a unit of meter per second squared. Meter is also what? A fundamental quantity. Time there is also a fundamental quantity. So which means that the force is actually a combination of one, two, three, the three fundamental quantities, the mass, the length, and the time, to give us what? Newtons. Whereas area is a combination of what? The length squared, or length times length, or meters times meters to give us meter squared. So which means pressure is actually a combination of more than what? Of combination of the three basic fundamental quantities in physics. And of course, this means that the unit of pressure, Newton per meter square, is what? A derived unit. And of course, pressure itself is a derived quantity because it depended on the three basic fundamental quantities to be defined. Okay. Now, having said this, I said earlier that among the six fundamental quantities listed, three basic fundamental quantities define every other quantity in physics. I've said that earlier, and they include what? The mass, the length, and the time. These three, of course, produces virtually all quantities in physics, as also can be seen in the pressure. You can see that there's a combination of the three quantities in pressure: mass for kilogram, meters for length, and of course second square for time. So you have the combination of the three of them to produce pressure. So the very best way to know if a quantity is derived or not derived is from where their unit. It's very easy from the units. Okay, so that being said, if a question is given to you and you're asked to pick if a quantity is a fundamental quantity or a derived quantity, or whether it's a fundamental unit or a derived unit, what you do is have a mental picture or a memory of what? The six basic fundamental quantities. Now, if you're being asked if it's a derived quantity and you look you remember your 6 basic fundamental quantities and they are not among, then it means you select the ones or the parts or the ones which does not involve the 6 basic fundamental quantities to be what the derived quantities. But if you're being asked which of these is a fundamental quantity, you have to always know your what fundamental quantities. Like you need to know them just like you know your name. If you know them, it's very easy for you to what not waste time on any particular question. You just go ahead and tick the options and you're good. All right, so that being said, we are going to pause the video here, and in the next video we are going to be reviewing past questions, previous years questions on that have repeated on this particular topic, 2021 and 2022, and we're also going to search if there is also a question in 2023 on this particular topic, and then we are going to review it. So do well to watch to the end of the video. Thanks. Welcome back. All right, so let's consider these past questions. This is Jamb 2022 and this is Jamb 2021 past questions on the board to actually explain the concept of fundamental and derived quantities. Let's start with 2022 question. Okay, the very first question in the Jamb 2022 question says, which of these is a derived unit? Which of these is a derived unit? Option A says kilogram, option B says meter, option C says newtons, option D says seconds. And I said earlier that there are three fundamental quantities, three basic fundamental quantities apart from the 6. There are three basic fundamental quantities and they include the mass, okay, the length, and the time. And these three basic fundamental quantities combine together to produce virtually every other quantities in physics. I said it earlier. Okay, and I said the unit of all fundamental quantities are simply called fundamental units. So the unit of mass is what? Kilograms, not forgetting. The unit of length is meters, not forgetting. Okay, the unit of time is what? Seconds, not forgetting. So, and I said that the units of the fundamental quantities are simply called fundamental units. Therefore, every other unit aside this unit are all called derived units. So let's look at the options now. We have kilogram. Kilogram is a fundamental unit, which is unit of mass. We have meter. Meter is a fundamental unit, which is unit of length. And then we have second as option D. Second is a fundamental unit of time. And we have here newtons. Newton is not a fundamental unit. It is simply what? A derived unit of force. So the correct option is what? Option C, which is Newton. Question says, which of these is a derived unit? So which means Newton is a derived unit. As explained earlier, Newton is a fundamental unit of force. Okay, force is measured in Newton, and we know that force itself is mass times what? Acceleration due to gravity. Okay, you can simply write G, mass times acceleration due to gravity, where mass is a fundamental unit. And of course, I said to always obtain fundamental quantities, and I said to always determine if a quantity is a fundamental quantity or a derived quantity. Always solve from the unit. Is very easy with the unit. The unit is the best approach to it. So we have mass, which is measured in kilograms. We have acceleration here is meters per second squared. So you notice that kilogram is a fundamental unit. We have meter here, which is a fundamental unit as well. We have second, which is also a fundamental unit. So force actually needed what? 3 fundamental units to combine to produce it. So which means force is a derived quantity and its unit, Newton, is what? A derived unit. So option C is the correct answer to that particular question. Now let's go to 2021 Jamb question physics. Now the 2021 Jamb physics says, which of the units of the following physical units are derived? Which of the units of the following physical units are derived? And they gave us the following units. We have the area, we have thrust, we have pressure, we have mass. And the options are I, and IV for option A. We have option B and option C and option D down. Now let's try to get the answer first from the units given to us. So we know that unit area, the unit of area is what? Meter squared. We've explained this earlier as well. And meter squared actually depended on what? The combination of meter times meter. So meter needed to multiply itself twice to give us the unit of area, which is meter squared. So which means meter, remember, is a fundamental unit. Meter as well is a fundamental unit. So area actually needed what? Combination of 2 meter or 2 fundamental quantity of meter to what? Produce its unit. So which means area is a derived unit. This is one of the derived units. Again, thrust is the same thing as force. Thrust is the same thing as force, and the unit of force is what? Newtons. And since we've already explained here that Newton is actually what? A derived unit. So thrust here is a derived unit. Okay. We also explained pressure earlier in the video, and we said pressure is simply, of course, newtons per meter squared by units. Okay. Pressure is Newton per meter squared by units. Newton is a derived quantity. Meter square is also obtained from area, which is also what? A derived quantity. So it means that the unit of pressure, of course, is also a derived unit. All right, so it's a derived unit. So the only underived quantity here, or the only fundamental quantity here, is mass. Mass is a fundamental quantity and not a derived quantity. So once again, the question says, which of the units of the following physical units are derived? So the only options that are derived here are what? and I are what? The derived quantities. Mass here is what? A fundamental quantity. So let's go through the options again and see. Option A says and IV. Obviously, this is not the option. That's not the correct answer. Option B says and IV, which is also wrong because IV here is mass. So this option is also wrong. This is not the correct answer. This is not the correct answer. Option C says I, and I only. So if we check again, and I, of course, these three are what? All derived units. So of course, this is the correct answer. Option D says I and IV only. So option B is also not the option D is also not the correct option. So the correct option is simply what? Option C. All right, so guys, that's it. There is no particular question on fundamental quantities or derived quantities in the 2023 Jamb pass question. So we'll actually have these two for you. In the next video, just like we've done here, we're also going to talk about the next topic, explain it so you can actually understand what the concept is all about. Then we end each of the videos with what? Past questions. Stay tuned, subscribe to this channel, and of course, like our videos, comment, and share to your friends which are also preparing for their Jamb examination in 2024. Do well to do all of this, and of course, subscribe to also get when the other videos will be dropping. So we are trying to make sure we cover all videos in maths, physics, and chemistry for you, just to help you prepare for your exams. Thank you guys. I will see you in the next video. Cheers.